Okay.
Okay, now we are discussing about some graph also. Big graph. See, impedance of the circuit is equal to Z is equal to square root of R square plus XL minus XC whole square. That is equal to square root of R square plus XL minus XC whole square. XL is equal to omega L, which is equal to 2 pi FL. And XC is equal to 1 divided by omega C, which is equal to 1 divided by 2 pi FC. Divided by 2 pi FC. So just I want to take one graph, impedance versus frequency. Impedance versus frequency. And mean the attain the resonance condition means FR is a resonance condition, resonance frequency. It's a very important RLC circuit. I mean the RLC circuit attain the frequency, resonance frequency, and before resonance frequency, the circuit acts as a capacitor circuit. It has capacitor. It's a very important condition because of listen to me is a very important graph also point of examinations. When attaining the resonance frequency, before resonance frequency, overall RLC circuit has acted as a capacitive circuit. If frequency is small, what happens? Impedance is large. Impedance is large because of X inversely proportional to F. After attain the resonance frequency, well, XL is equal to XC. Overall impedance of Z is equal to also the current is maximum. When after frequency, after resonance condition, above FR value, frequency increases. Frequency large. If frequency large means now the circuit behave as inductive circuit. It's very important. First one, listen to me. Attain resonance condition. Attain resonance condition, XL is equal to XC, Z equal to R, resonance frequency, F is equal to resonance frequency, F is equal to 1 divided by 2 pi square root of LC. Square root of LC. This is VL, this is VC, this is VR. You know well. Overall phase angle between VL and VC is 180 degree. So very important one. So VR flow of current in phase. I and R in phase because alternative current with the resistor. So there is no in phase angle. And alternative current with the inductor voltage lead of 90 degree. And alternative current with the capacitor current lead of 90 degree, lead by voltage lag, current lead phase angle by 90 degree. So this is, the overall phase difference between VL and VC is equal to 180 degree. So VL plus VC is equal to 0. If VL value equal to 1 means VLC is equal to minus 1. VL is equal to minus VC. 180 degree out of phase. It's a very important condition. Now we are discussing about the topics. F is equal to small means. F is small means the attained resonance frequency at reach to our resonance frequency. Before resonance frequency, RLC circuit behave as capacitive circuit. Capacitive circuit. After resonance frequency, reach resonance frequency, this is conditions of resonance frequency. FR is equal to 1 divided by square. FR is equal to 1 divided by 2 by square root of LC. Now after resonance frequency, if frequency large increases, what happens? It acts as an inductive circuit. That is also large. This is very important condition in examination, NEET examination. See, F is small. I want to consider 2 points. A small F. This is FA. This is FB. If FA is a small value, Z large. Impedance large means what happens? Current decreases. So impedance large. This is maximum value. Impedance large. And F large means after frequency, FB point of FB. Z is also large, which means this point is also Z large. At resonance frequency, what happened? Z equal to R. Z equal to R. I mean Z minimum which is equal to R. I mean at a resonance condition, Z value is reduced to comparison remaining two conditions. So Z is a very minimum value. Z minimum is equal to R. So Z is reduces. This is Z versus frequency. This is a very important one. Z versus frequency. Overall impedance and the frequency graph. Impedance and frequency graph. This is the minimum low frequency, Z large. High frequency is also Z large. That is, the curve is rich. And this is frequency reduced at minimum at resonance condition. Z minimum at resonance condition, which means Z is equal to R. Z is equal to R. When attain this condition, Z equal to R, current maximum. Current maximum. And next graph is in our textbook. See, next graph, current versus frequency. Current versus frequency. In our textbook, see this. Current and frequency. If frequency is small, Z large. If impedance maximum means current. What happened current minimum? Because of I maximum is equal to V maximum divided by Z. Condition F small, Z large. If Z large means current minimum. Z large means current minimum. When minimum small frequency, current minimum, so reaching this point, get the current graph. This is resonance frequency condition. At reach the resonance frequency FR, when the minimum frequency FA, and this is FB. FA and FB. FR is nothing but it's a resonance frequency. FA is the lower band frequency, FB is the higher band frequency. You study detail in a 10th lesson communication system. So FB is the upper band frequency, FA is the lower band frequency. The difference between FB and FA is nothing but is a bandwidth. Detail is studied about in 10th lesson. Just I want to take the graph. So I maximum is equal to V maximum divided by Z. When FA value is a small value, F small means Z large. Z large means current minimum. So this is minimum current. And F maximum means F large. Z is also large. Z large means current minimum. So at resonance condition, you know well, at resonance condition, Z equal to R, the overall impedance of the circuit reduces. So Z almost equal to R. Now Vm divided by R. So I maximum, which is equal to V maximum divided by R. When Z is goes to R, convert to R. Overall impedance of the circuit is reached to R value. Purely resistive circuit. So at reach the resonance condition, current maximum, and FR reaches the current maximum. This is I maximum. Current maximum. At the frequency condition, current maximum. Lower band frequency low value, current minimum. Upper band frequency, current minimum. This is minimum current. This is maximum current. At resonance condition, attain maximum current. It's a very important one. And this region R value is very small. R value is small. So current maximum and region resonance frequency. And another one, if for example this point is R means the current maximum current is almost equal to 10 ampere, for example. And same this. Now this is also attained resonance frequency. This curve is also, this curve is R, this curve is R. This curve is also attained the resonance frequency, but resistance is 2R. Resistance is 2R. Bandwidth is maximum. What happened? Compare the first one. This is FA, this is FB. bandwidth. See this, and resistance is 2R. Resistance is 2R. I mean, attain the resonance frequency, resistance is R, the current maximum. If 2R, almost the maximum current reaches to 10 ampere means, and same second curve is also reached in resonance frequency. But the resistance is 2R means this is the maximum current. What is this maximum current is equal to? If resistance 2 times increases, current 2 times decreases, so 5 ampere. 5 ampere. Another one curve. Another one curve. This is also attained resonance frequency. Same reach in resonance frequency. But the resistance is, the curve is very, very flat. So resistance increases. Curve is 4R. What happened? The resistance is 4R, but attain the same resonance frequency. But current is maximum, attain the 4R resistance. 4R resistance, which is equal to 2.5 ampere. But this is also resonance condition. This is also resonance condition. But the resistance value is double. And the resistance is small, the current is maximum. This is a pure resistive circuit, and this is a resonance conditions of RLC circuit. So very important, another one topic, F is equal to 1 divided by 2 pi square root of LC, resonance frequency. The resonance frequency is mainly depends on L value and C value. It is a very important. See this. Listen, the exam, most of examinations are asking like these questions. Listen to me. Fr is equal to 1 divided by 2 by square root of LC. The resonance frequency is mainly depends on L value and C value. Is independent of R value. Resonance frequency is independent of resistance. But attain the maximum current, I maximum, which is equal to Vm divided by R. The maximum current is depends on resistance. At resonance conditions, you have on some resistance value. At resonance frequency, Fr is equal to attain on some, the sharp curve. Sharp curve. The curve will reach in maximum sharp. The current maximum and the resistance very, very, very low. Current is a very, very maximum at the frequency Fr. That is what happened. The sharper curve should act as a pure resistive circuit. That's why it's called as filter circuit, and is also voltage magnification circuit option. Because I will explain this how we convert to voltage maximum multiplied by these conditions. R is equal to small. If R is equal to small means current is maximum. Current is maximum. So the maximum current depends resistance. Depends resistance, but resonance frequency is independent of the resistance. Depends only L and C value. L and C value. It is a very important. The curve, if curve is very flat means resistance maximum. The curve is very sharp means the resistance R values are very small. Current maximum. Current maximum. That is called as pure resistive circuit. This is called as pure resonance RLC series circuit. RLC series circuit. It's a very important. And next one is, this is effects of RLC series circuit. And next one is application of RLC series circuit. It is a very important one. Application means commonly they act as a filter circuit and voltage multiplier and oscillator also. But main application is radio tuning circuit. Tuning of circuit of radio system. Tuning circuits of radio system. See graph. This I value, this F value. The frequency curve is reached. This is a resonance frequency, Fr. Okay. The frequency is equal to, what is the frequency? F is equal to 1 divided by 2 pi square root of this. And most of the circuit, capacitor is act as a tuner. Capacitor act as a tuner. If the radio knob rotate, which means the capacitor value should be changed. Radio knob And these circuit, resonance or RLC circuit, act as applications, very important applications, filter circuits, act as oscillators, act as a voltage multiplier, and is a very important application, tuning circuit in radio system and TV system also. In radio system, by changing the knob, changing the radio knob. Knob, you know well, the knob means is nothing but whose is capacitor. If the capacitor value should be changed or inductive values also change, when the capacitor is constant, the frequency should be changed. FR will also change. If the capacitance value change, the resonance frequency is also changed. At reach the resonance condition, frequency should be changed. If C value changes, corresponding to the frequency is also changed. When reaching resonance condition, particularly one radio station should be reached. And number of frequencies and number of radio stations available in space. But in particularly one radio station should be selected. That's why it's called as filter circuit. Remaining radio stations should be neglected because of select, but only one frequency should be selected by this RLC resonance circuit. That's why it's called as filter circuit. For example, just I want to take two radio system. I made FM, Suryan FM 93.5 MHz and Radio Mirchi 98.3 MHz. This frequency is 93.5. This frequency is 98.3 MHz. 98.3 MHz. For example, this resonance frequency attained in one particular 93.5 radio station, Suryan FM, reach. And this is a resonance frequency of RLC circuit. In radio station, simply the circuit is RLC. This is C inductor. This is resistance. R C L. When serious, this is an electromagnetic wave. You know well, electromagnetic wave. Most of the radio station should be spread in electromagnetic wave in space. Particularly, one radio station should be selected. This is a radio. This is radio knob of radio RLC circuit. Radio knob. When the C value changes, a frequency corresponding to changes. When the frequency is natural frequency of RLC circuit is attain the particular radio station frequency. This is conditions of RLC. I mean the resonance condition. Conditions of RLC. I mean the resonance condition. Resonance RLC circuit. When the C value changes, frequency is also changes and reach in resonance condition 93.5 MHz when we receive Suryan FM. For example, this is 93.4. This is 93.6. If 93.6 produces one current, 93.4 produces same current. I mean, this current is minimum. This current is minimum. There is no any signal from received from this condition because of this is resistance is maximum. When resonance reach 93.5 MHz frequency reach, that is called resonance frequency. The Z value is reduced to R. The minimum overall the impedance of the circuit is received decreases. Z is equal to R. If Z is equal to R means the impedance of the circuit increases. Current is maximum. This is maximum current. I maximum. Current maximum. These frequencies should be received. Remaining radio station frequency should be negated. That's why the circuit is called as filter circuit. Remaining radio stations are not selected, but only reach in FR value 93.5 MHz. That frequency should be selected. If reach the resonance condition, at the conditions, the signal should be received by the resonance of RLC circuit. And what happens if 98.3? This is 98.3 radio Mirchi received. Sir, 98.3 radio Mirchi resonance condition. If C value changes, F is also changes and reach to 98.3 frequency, 98.3 megahertz. What happened? If received radio radio station, that signal should be received by the conditions of 98.3 and resonance condition. Same time, we are obtained 90. See, this is 93.5 signals is also received. This is very important. Sir, reach 98.3 megahertz at resonance conditions are receive current maximum. So the radio which signal should be received by the resonance RLC circuit. What happens, sir? 93.5 also received, but the reach in the current value is a minimum. It's a very important. 93.5 megahertz frequency is also received. It's not a resonance condition. At the time, reach 93.5, but the current is a minimum. Current is minimum, so the signal is negligible. Selected. I am not selected. Only selected by the 98.3 megahertz frequency. So at reaching condition, this is radio current maximum. Current maximum. Remaining radio station signals would be not selected. So this is resonance conditions of, I mean the tuning circuit. Tuning circuit of radio system. Tuning circuit of radio system or TV system. It is a very important applications of resonance RLC circuit. Resonance RLC circuit. And next one is what do you mean by quality factor? Next one important topic is quality factor. Quality. Next topic. Q factor or quality factor. Q factor or quality factor. Q factor is nothing but how many times the voltage should be multiplied or magnified. It's a very important condition. See, this is R, this is inductor, and this is capacitor. Applied voltage, alternating current. B is equal to Vm sin omega t. This is R, this is L, this is C. Voltage across R is VR, voltage across inductor is VL, and voltage across VC equal. VL, I mean voltage across capacitor is VC. When reach and resonance condition, XL is equal to XC, Z is equal to R. The RLC circuit must be act as a purely resistive circuit. These applied voltage which is equal to VR. V is equal to VR. It's a very important sir to me, all of you. Applied voltage, attain the resonance condition, applied voltage which is equal to voltage across VR. So current in circuit is I. So V is equal to VR, I mean Vm is equal to VR. Maximum voltage is equal to VR, or V is equal to VR. Omega t value is equal to 1. Sin omega t is overall value is equal to 1. V is equal to Vm. But V is equal to VR. Applied voltage which is equal to voltage across VR at resonance condition. What happened? The voltage across VL and voltage across VC. VL and VC, phase diagram. This is VR, this is VL, this is VC. The VL and VC phase difference between VL and VC is 180 degree out of 180 degree. So VL plus VC is equal to 0. VL is equal to minus VC. It is a very important condition. Very important. Listen to me. This is one and this is one. See, when reach in resonance condition, the voltage across VL or voltage across VC is much greater than the applied voltage. Much greater than the applied voltage. It's a very important condition. That's why the resonance RLC circuit is called as voltage multiplier or voltage magnification. Voltage magnification circuit. So V is equal to Vm sin omega t, which means V is equal to VR plus VL plus VC. V is equal to VR plus VL plus VC. VL plus VC value is equal to 0 because of their two voltage are out of 180 phase difference. That's why the value is equal to 0. So V is equal to VR. V is equal to VR. At resonance condition, V is equal to applied voltage is equal to voltage across resistance. Voltage across resistance. So voltage across VL and voltage across VC is much greater compared to applied voltage. Applied voltage is a very important one. And what do you mean by quality factor? What do you mean by quality factor? Quality factor is nothing but how many times is much multiplied or how many times is much greater than the applied voltage of voltage across VL and VC. I mean the simple definition of quality factor. Quality factor is nothing but Q factor is nothing but quality factor. Q factor is equal to, simply called as a Q factor, which is equal to voltage across L or C. Voltage across L or C divided by applied voltage. Divided by applied voltage. Q factor, which is equal to, simply called definitions of the ratio between voltage across L or C and applied voltage. At resonance, what happened? Well, quality factor definitions. I want the equations of quality factor. Voltage across L, whose is voltage across L, BL, divided by applied voltage V. Applied voltage V. V is equal to Vm sin omega t. But resonance condition, the circuit must be at resonance. This is quality factor is nothing but good conditions of resonance, good resonance. To decide the good resonance. Quality factor Q is equal to voltage across L or C divided by applied voltage. Voltage across VL is equal to what is the formula? I into XL. V is equal to IR. Voltage across VL is equal to IXL divided by V. V means applied voltage. Applied voltage is equal to voltage across resistance when resonance condition. So which is equal to IXL divided by VR is equal to IR. VR divided by IR cancel. So quality factor Q is equal to XL divided by R. XL divided by IR. So which is equal to XL is equal to omega L. You know well. XL is equal to omega L divided by R. Omega is equal to, at resonance, omega is equal to 1 divided by square root of LC. Omega is equal to 1 divided by square root of LC. So L divided by R into omega. Omega is equal to 1 divided by square root of LC. So quality factor Q is equal to L value root L into root L divided by R into root L into root C. So root L cancel. So which is equal to 1 divided by R whole square root of L divided by C. L divided by C. This is quality factor equation. Quality factor equation. Q is equal to 1 divided by R square root of L divided by C. L divided by C. This is a quality factor equations. The quality factor is nothing but how many times the voltage multiplied by the equations, by the RLC circuit resonance condition. Q is equal to 1 divided by R square root of L divided by C. The quality factor must be set to the sharpness of the resonance in frequency F, current I. And the circuit is reaching sharp point. If the sharp point, listen to me, this is a FR value, current maximum, I maximum. This sharp point, In this region, R value is a very small, so current maximum. Current maximum. So maximum current attained means the resonance conditions is a very sharp. I mean the sharp point, sharpness of the this graph. I mean this is selector by quality factor. So Q is equal to sharpness of the circuit or resonance of the circuit, or how many times multiplied by the increase or multiple the voltage by the voltage across L or voltage across C. So Q is equal to 1 divided by R square root of L divided by C. In same phenomena based on the C value, voltage across C, the quality factor Q is equal to voltage across L or voltage across C. So VL divided by VR, which means applied voltage V, applied voltage is equal to VR. So VL is equal to VL is equal to IX VL. Now we are discussing about capacitor. Already we see the VL value. Now we are see the capacitance of VC divided by VR. So XC divided by IR. I cancel. XC is equal to 1 divided by XC is equal to 1 divided by omega C. So 1 divided by R into XC value is 1 divided by omega C. So which is equal to 1 divided by RC into 1 divided by omega is equal to 1 divided by square root of LC. So which is equal to RC 1 divided by RC into square root of LC. So which is equal square root of L into square root of C divided by R into C value root C into root C. So C cancel. The final value quality factor Q is equal to whole square root of 1 divided by R into whole square root of L divided by C. This is also quality factor based on the capacitance. And this is based on the inductive. Both are equal. So Q is equal to 1 divided by R square root of L divided by C. C quality factor Q is equal to 1 divided by R square root of L divided by C. If R value is small, quality factor, what happens? Quality factor increases. If R value is small, quality factor large. If C value is small, quality factor is large, maximum. If R value is small, C value is small, quality factor is large. If L value is large, Q is also large because of directly proportional. Directly proportional. The quality factor is depends upon the resistance, inductor, and the capacitive circuit. And next one, quality factor Q is equal to quality factor Q is equal to this is a formula VL divided by VR. VL divided by VR. Quality factor Q is equal to at resonance condition VL divided by VR. You know well applied voltage which is equal to the voltage across resistance VL divided by VR. VL is equal to I want this VL voltage across inductor which is equal to Q into VR. Q into VR. Voltage across VC equal to voltage across capacitance is equal to Q into VR, which means VR is equal to applied voltage. I mean voltage across resistance, but resonance condition which is V is equal to VR. That's why I want to take V is equal to VR. So VL is equal to Q into QR. Q is nothing but a quality factor. This is constant value. Almost these values reach to range of 10 to 100. 10 to 100. So VL is nothing but voltage across inductor. VC is voltage across capacitor. When the circuit we are applied alternating voltage, almost consider yes If applied voltage V is equal to VR is equal to 240 volt. You know, well, the alternating voltage maximum range 240 volt. So our voltage across VL is equal to voltage across VL is equal to the Q value is mostly the range of 10 to 100 and maximum perfect. I mean, it depends upon the circuit and the values. Maximum value reach to 200 also. Maximum most of commercial values 10 to 100. If just I want to take Q value is equal to 20 means quality factor is 20 means into VR is equal to applied voltage is 240. So the voltage across VL is equal to 4800 volt. See, applied voltage is 240, but the voltage multiplied by resonance RLC circuit is 4800 volt. 4800 volt. That's why the resonance RLC circuit we are called voltage multiplier or voltage magnification. Voltage magnification. It is a very important voltage multiplier. VL is equal to R, VC is equal to 4800 volt hours are developed when the resonance condition of RLC circuit. But applied voltage is 240 volt. 240 volt. For example, Q is equal to 10 means 2400 volt. Just reach to VL is equal to just Q is a minimum Q value. 10 into 240 is equal to what's this? 2400. 2400 volts should be developed across voltage across inductor or capacitor. That's why the circuit RLC resonance circuit is called as voltage multiplier. Voltage multiplier is a very important. And these topics are most of these topics are based on the example point of view. First one is what do you mean by RLC circuit in series, the conditions, a phasor diagram and voltage phasor diagram and a resistor impedance diagram, phasor diagram and Z value that is equal to square root of R square plus XL minus XC whole square. And the conditions case 1, case 2, case 3, XL greater than XC, XC greater than XL, and XL is equal to XC is very important. That is a resonance condition, and the circuit is overall circuit should act as a purely resistive circuit, And next one is resonance. Resonance means omega is equal to resonance in RLC circuit means omega is equal to 1 divided by square root of LC when the frequency of applied source is equal to natural frequency of RLC circuit. That is called as a electrical resonance, and reach the electrical resonance. The frequency is called as a resonance frequency. Resonance frequency formula is 1 divided by 2 pi square root of LC. That's the resonance frequency. And next one is effects of resonance frequency, and you know the effects that is equal to R. The RLC circuit is act as a purely resistive circuit. XL is equal to XC, and pi value is equal to 0. There is no any phase difference between voltage and the current because of act as a purely resistive circuit. Z value is equal to reach to R. So the maximum current I maximum is equal to V maximum divided by R. I mean Vm divided by Z, but Z is equal to R. That's why Vm divided by R. So Z value reduces, so current maximum. That is resonance condition. And reach in resonance condition, the current is maximum. That's why it's called as a filter circuit. You know well. I will explain this. Already explained. Graph I and F. I and F. See, this is resonance condition. This is a band with upper band frequency. This is lower band frequency, and this is also reach in resonance condition, but the current is minimum, so it's not a resonance circuit. And this is a reach and resonance point when the attained Z value is equal to R, current maximum. This is purely resistive circuit, act as a purely resistive circuit. And applications, radio system, radio tuner, act as a radio tuner. And next one is amplification, voltage amplification factor, which means quality factor. Q factor is equal to voltage across inductor or voltage across capacitor divided by applied voltage. So Q factor value, Q is equal to, what's the formula of Q is equal to 1 divided by R square root of L divided by C. L divided by C. Q is inversely proportional to resistance. If R small, C value small, quality factor is maximum. Most of the system in practical life, today in our practical life, C is act as a tuner. Most of them. Sometimes C value changes, sometimes L value changes. So R and C value is a small, quality factor is maximum. If L value is large, quality factor is also large. It's a very, very, very important. Okay, thank you, students. We will discuss and we will meet in next class. So what do you mean by, please? Students, I asked some question. What do you mean by resonance condition? Hello? Okay, thank you to all. Hello? Anybody say, what do you mean by resonance condition? What happened resonance condition? What was the impedance of the circuit? What happened Z value? Hello? Do you hear my voice?
That value is equal to R.
Very good. That is equal to R. And next. And next. XL is equal to
XL equal to XC.
XL is equal to XC. And very good. Next, what happened pi value? Who's this pi?
Pi value becomes 0.
Becomes 0. Very good. Who's pi? Pi is nothing but the phase difference between voltage and current. At resonance condition, RLC circuit must be act as, behave as. Hello? At resonance condition, the RLC circuit behave as pure resistive circuit. Very good. Pure resistive circuit. Okay, students, we will meet next class. And example problems are available in our textbook. Just practice it. Thank you. Thank you to all.